Scientific notation. Scientific notation is a special way of writing extremely large or extremely small numbers. For example, the number of atoms in 1 gram of carbon is more than 5,000,000,000,000,000,000,000,000,000,000. This number is very large and quite inconvenient to write, so scientific notation is used. This number can be written in scientific notation as 5.0 times 10 to the power of 22. This means that 5.0 must be multiplied by 10 22 times in order to get this large number. Scientific notation is commonly used in astronomy, science, engineering, business, and geography. A number in scientific notation is written in the form of a times 10 to the power of n, where a is greater or equal to 1 but less than 10, and n is an element of the natural number set. So the n, the power, must be a positive whole number. So for example, 4.54 times 10 to the power of 3. So this number is written in scientific notation. So the a is 4.54. So this number, 4.54, is greater than 1, greater or equal to 1, but less than 10. So it's some number in between 1 and 10. So a handy way to think about it is that the decimal point goes after the very first digit. So the first digit here is 4, so we have our decimal point. Next we have a multiplication symbol. So scientific notation always starts with some number, so some number that we call a, and then it always has a multiplication symbol next. It's not addition, it's not division, it's not subtraction, it must be a multiplication symbol. And then it always ends with 10 to the power of something. So 10 to the power of n, 10 to the power of 3. So that's something, that n, for ordinary level junior cert, will always be a positive whole number. So if you were to do higher level junior cert, or if you were to do leaving cert maths, this can be positive or negative. But for ordinary level junior cert, it will only be positive. So I will be doing another video where we see examples of positive and negative powers of 10. So here's our number, 4.54 times 10 to the power of 3. So this is written in the form of a times 10 to the power of n, where the a is greater or equal to 1 but less than 10. So that number 4.54 is somewhere in between 1 and 10. And the n, the power, is an element of the natural number set. So it's a positive whole number, in this case it's 3. So the number with the decimal point after the first digit, in this case it's 4. And the 3, this shows how many places to move the decimal point. So if this is a positive number, which it is, it's positive 3, we move the decimal point to the right. So the decimal point at the moment is here. We're going to move it 3 places to the right. To work out the correct power of 10, we need to move the decimal point so that there is a digit from 1 to 9 before the decimal point. So this is if we were going from a large number into scientific notation. So let's have a look at some examples. Write each of the following numbers in scientific notation. So here we have 23 million, so 23 and 6 zeros. So this is a large number. So we're going to write it out as it is. So we've 23 and then 1, 2, 3, 4, 5, 6 zeros. So this is a large number and it's a whole number. And at the end of every whole number we have an invisible decimal point. So I'm going to draw in our invisible decimal point there. So we want to move this decimal to the left so that it's after the very first digit, and the very first digit is 2. So I'm going to move that decimal to the left, so I have to move it 1, 2, 3, 4, 5, 6, 7 times, and now I'm going to write in the new position. So now I have 2.3, and I can just forget about all the other zeros because after the decimal point, zeros don't count unless there's some other non-zero digits after it. So we just have 2.3. So remember, scientific notation is always in the form of a times 10 to the power of n. So the a must be some number in between 1 and 10, and 2.3 is definitely in between 1 and 10. So the trick is you just move the decimal until it's in between the first and the second digit. So 2.3 represents the a, and it is some number in between 1 and 10. So next we have our multiplication symbol, and then we're going to have 10 to the power of something. So to figure out what that something is, we have to see how many places did we move the decimal. So it started here at the back and we went 1, 2, 3, 4, 5, 6, 7. So this becomes 10 to the power of 7. So here we had a large number, 23 million, and we were asked to write it in scientific notation, which means in the form a times 10 to the power of n. And here we have it 2.3 times 10 to the power of 7. So that means 2.3 gets multiplied by 10 to the power of 7, or 10 7 times, and it will give you 23 million. Next we have the number 800. So we do the exact same thing. 800 is a whole number, so the decimal happens to be right here. It's an invisible decimal because there is none. So I start off by writing in my invisible decimal. Now I want to move that decimal point so that it's in between the first and the second digit, so that the number that I have is somewhere in between 1 and 10. So I move it 1, 2 places to the left, and I write in my new decimal. So it's after the 8 and in front of the 0. So I'm going to write 8.0 underneath. So that's the A part. So remember, the A must be a number in between 1 and 10. So 8.0 is definitely in between 1 and 10. It's bigger than 1 but less than 10. Next we have our multiplication symbol. And then finally we have 10 to the power of something. So to figure out what that power is, we have a look at the decimal. So there's the decimal point, and we moved it 1, 2 places to the left. So this becomes 10 to the power of 2. So we were asked to write 800 in scientific notation, which means in the form of a times 10 to the power of n, and that's 8.0 times 10 to the power of 2. So I'm going to do one more example. So let's say we have the number 798.32. Now 798.32 is actually quite close to the number 800, isn't it? So we want to change this now into scientific notation. So that means in the form of a times 10 to the power of n. Now in this example, we actually have a decimal already in the question. In the other two examples, there was no decimal, so we had to draw them in. But since this is already given to us, all we have to do is move this to the left until it's in between the first two digits. So that's what I'm going to do. So I'm going to move the decimal point that's already there to the left until it's in between the first two digits. So then I'm going to write down the number again. So now I have 7.9832. Now remember, I moved that decimal point. I moved it in between the 7 and the 9. So I don't write it down again here. So I have 7.9832. So I want to write this in the form of a times 10 to the power of n, where a is a number in between 1 and 10. So 7.9832 is definitely bigger than 1 but less than 10, so that's fine. Next we have a multiplication symbol. And then we have 10 to the power of something. So to figure out what that something is, we want to see how many places did we move the decimal point. We moved it 1, 2 places to the left, so it becomes 10 to the power of 2. And that makes sense that it should be 10 to the power of 2, because 800 worked out to be 8.0 times 10 to the power of 2. And 798.32 was quite close to 800, so it makes sense that that would also be 10 to the power of 2. Write each of the following in decimal form. So we have 9.1 times 10 to the power of 4 and 2.43 times 10 to the power of 7. So hopefully you recognise that these are in the form of a times 10 to the power of n, which means that they're in scientific notation form. So we want to change them back into normal numbers. So 9.1 times 10 to the power of 4. So I'm going to just write that down. So I want to change this into a bigger number. So I'm going to take the 9.1 and write it down underneath. And then I'm going to move the decimal 4 places to the right because I need to make this number bigger. So 1, 2, 3, 4. So there's my new decimal point. And notice now that I have 3 empty archways. So the first archway that I have has a 1 underneath, so that's fine. But then I have 1, 2, 3 empty archways. So what I'm going to fill in underneath those empty archways is zeros. So this is a bit messy looking, so I'm just going to write it out again without the archways, and I'm going to use the new decimal point. So I have 91000 and the decimal point. So I have 91,000, so I'm going to put a little comma after the 1. So I have 91,000. And I can actually rub out that decimal point at the end because we don't say 91,000 point nothing. If there was some other digits after it, we could have it in there. But we don't, so we're going to just get rid of that decimal point. So we were asked to change the number 9.1 times 10 to the power of 4 into decimal form, which means into a big number. So we got 91,000. Now, something to be really careful of. Sometimes when people see 10 to the power of 4, they think, oh, I just draw 4 zeros. That's not correct. It means you move the decimal point that's given 4 places to the right. And if there's any empty arches, then you put zeros underneath them. There happen to be 3 empty arches in this question, so we filled in 3 zeros. Okay, next question, 2.43 times 10 to the power of 7. So we start off by writing out the A, the 2.43, and we're going to move the decimal point that's given to us 7 places to the right because the power is 7. So 1, 2, 3, 4, 5, 6, 7. So there's our new decimal point. And notice that we have a few empty arches, so we're going to fill in zeros underneath those empty arches. So we fill in 1, 2, 3, 4, 5 zeros. So again, just like with the last example, don't make the mistake and think the power is 7, so I write in 7 zeros. That's wrong. You move the decimal point that's given 7 places to the right, and any empty arches get zeros. So this is a bit messy looking, but you should do your rough work in your exam. You should draw this out as it is and draw the arches and everything and the decimal point being moved. But then underneath you should write it out a bit neater. So we have 2, 4, 3 and then 5 zeros. And we have our decimal now at the end. So remember, we moved that decimal right the way to the very, very end. So this number is 243 0, 0, 0, 0, 0. So that is 24,300,000. So I've put in some commas in between. I start at the very right and I move backwards by 3 digits, and I move backwards by another 3 digits to put in my commas. So I have 24,300,000. So I'm actually going to rub out this decimal point here because it doesn't make sense to say 24,300,000 point nothing. So I was asked to write 2.43 times 10 to the power of 7 in decimal form, and I got 24,300,000. So I'm going to do one more example. So let's say we're given 6.0 times 10 to the power of 3, and we want to write that in decimal form. So as a normal number, as a big number. So we start off by writing out the 6.0. And we're going to move the decimal point 3 places to the right because we have 10 to the power of 3. So 1, 2, 3 places to the right. There's my new decimal point. And underneath any empty arches, I put some zeros. So I put a 0 there and another 0 there. And then I write it out again. So I have 6, 0, 0, 0. And the decimal point is now at the end. But it doesn't make sense to say 6,000 point nothing, so I'm actually going to rub out that decimal. And I'm going to just put in a comma after the 6 because it represents 6,000. Addition and subtraction of numbers in scientific notation. So if we want to add or subtract numbers that are in the form of a times 10 to the power of n, so scientific notation, we rewrite the numbers in decimal, ordinary form, and add or subtract the numbers. And then we rewrite the answer in scientific notation. And we want to do multiplication or division. So multiplication and division of numbers in scientific notation. Separate the numbers into decimal part and the index part and multiply or divide using the rules of indices. Write the answer in scientific notation. Calculate each of the following and give your answer in scientific notation. So let's start with number 1. 3.8 multiplied by 10 to the power 6. So this is in scientific notation. This is in the form of a times 10 to the power of n. Multiplied by 2.1 times 10 to the power of 5. So again, this is in the form of a times 10 to the power of n, so scientific notation. So we're multiplying two scientific notation numbers. In the next example, we will be adding, but in this example, we are multiplying. So this is the question that we're focusing on here. So we can multiply in any order we like. So what that means is multiplication and division are different, obviously, we know that. But with multiplication, 2 times 3 will give us 6. And likewise, 3 times 2 will give us 6. So multiplication, the order does not matter. Just like with adding. 2 plus 3 gives us 5. 3 plus 2 also gives us 5. So with adding and with multiplying, the order does not matter. Whereas with subtracting or dividing, the order does matter. So we have to be careful if we're subtracting or we're dividing because the order in which we do it matters. But with multiplying, it doesn't. So we can multiply in any order we like. So what we're going to do is separate the decimal parts and the index parts and multiply. So the decimal parts, 3.8 and 2.1. So 3.8 times 2.1 is 7.98. Next we multiply the index parts. So 10 to the power 6 times 10 to the power 5. Multiplying powers with the same base, we add the powers. So 6 plus 5 gives us 11. So this is using the rules of indices. So we get 10 to the power of 11. So then we just put them together. So we have 7.98 times 10 to the power of 11. We don't have to do anything to this because this number is already in between 1 and 10. So 7.98 is bigger than 1 but less than 10. So there's nothing needed to be changed here. So this is our answer. Alternatively, you could have just put it into the calculator using our x10 to the power of x button. So we have 3.8 times 10 to the power of 6. So you type into the calculator 3.8 x10x button 6 multiplied by, and then we have 2.1 times 10 to the power of 5. So 2.1 x10x 5. And then equals, and you will get the same answer. Alternatively, you could have typed this in exactly as you see it into your calculator using the brackets. That's very important. And again, you would have got this as an answer. Question 2, 9.5 times 10 to the power of 3 plus this time, so we're adding this time, 2.8 times 10 to the power of 2. So what we can do here is write the numbers in decimal or ordinary form and add them. So 9.5 times 10 to the power of 3 gives us 9,500. And 2.8 times 10 to the power of 4 gives us 28,000. And adding these gives us 37,500. And then we just change 37,500 into scientific notation. So we get 3.75 times 10 to the power of 4. Or we could have just used the calculator and typed in 9.5 x 10x 3 plus 2.8 x 10x 4. We would have got 37,500, which we then could have changed into scientific notation. So I'm just going to show you again how this becomes scientific notation. So 37,500, we don't see a decimal, so we can draw in the invisible decimal that's at the end. We want to move the decimal to the left until it's in between the first and second digits. So we move it 1, 2, 3, 4 places to the left. There's our new decimal point. So we have 3.75 times 10 to the power of something. So we moved that decimal point 1, 2, 3, 4 places. So it becomes times 10 to the power of 4. So that's where we got that number from. So alternatively, a third way of doing this is to literally just type this into the calculator exactly as you see it, including the brackets. And when you do that, you will get 37,500, which then you can change into scientific notation.